Hello, chemistry students. Today we're going to talk about pH and pOH. Now, the first thing that you need to know is that pure water's concentration, hydronium ion concentration, or H plus ion concentration. Now, the hydronium ion is H3O plus, and remember these brackets mean concentration. So the H plus concentration is equal to the hydroxide ion concentration, which is OH minus, and that happens to be equal to 1 times 10 to the 7th molar. So the H plus or H3O plus concentration is equal to the OH minus concentration, which is why water is neutral. The acid part, which is H3O plus or H plus, is equal to the base part, which is OH minus, so that makes it neutral, which is 1 times 10 to the minus 7th molar. Now, Kw is known as the ionization constant of water, and if you take the acid concentration, which is H plus or H3O plus, times the base concentration, which is OH minus, you multiply those two concentrations together, you will get 1 times 10 to the minus 14th molar squared. In dilute aqueous solutions, you can find the concentration of the hydronium ion. Remember, hydronium is H3O plus, or the hydroxide ion, which is OH minus, and then determine if the solution is acidic or basic. Now remember, the hydronium ion concentration times the hydroxide ion concentration is always equal to 1 times 10 to the minus 14th molar squared. You can tell if it's acidic or basic by looking at the concentrations. Now you know H3O plus or H plus concentration is equal to the acid part, and OH minus is equal to the base part. So if there's more acid than there is base, or the hydronium ion concentration is more than the base concentration, then the solution will be acidic. Now if they're equal, then obviously it's neutral. There's no more of one than the other. And if it's the opposite, where the acid part, the hydronium ion concentration, is less than the base part, which is the hydroxide ion concentration, then the solution is going to be basic. So let's do an example. If the concentration of the hydronium ion in a solution is 3.3 times 10 to the minus 14th molar, and the concentration of the hydroxide ion is 3.0 times 10 to the minus 1 molar, is the solution acidic, basic, or neutral? So now we have to ask ourselves, which one is greater? 3.3 times 10 to the minus 14th or 3.0 times 10 to the minus 1? Well, 3.3 times 10 to the minus 14th is the same thing as moving this decimal point to the left 14 times, which will be 0.000000000000033. Now 3.0 times 10 to the minus 1 molar is the same thing as moving the decimal place 1 to the left. So that would be 0.30. Now which number is bigger? The H3O concentration or the OH minus concentration? Well, looking at these two numbers, it will be the OH minus concentration is bigger. And if that's the case, then it is basic. Now let's look at another problem. If the hydronium ion concentration in a solution is 2.3 times 10 to the minus 6, we need to find out what the hydroxide ion concentration is. Now if we look at our formula here, in order to find the hydroxide ion concentration, we have to divide by the hydronium ion concentration. Since these two are multiplied together, we need to move this to the other side. In order to do that, we have to do the opposite, and that is divide by the hydronium ion concentration. So when we divide each side, whatever we do to the left side, we have to do to the right side. When we divide each side by the hydronium ion concentration, these two cancel. So the OH, or the hydroxide ion concentration, is simply equal to 1 times 10 to the minus 14th molar squared divided by the hydronium ion concentration, which we know is 2.3 times 10 to the minus 6 molar. So if we take 1 times 10 to the minus 14th divided by 2.3 times 10 to the minus 6, we are going to get 4.3 times 10 to the minus 9th molar. And that's what the hydroxide ion concentration is. Now we need to find out if it's acidic, basic, or neutral. So we have to ask ourselves which number is bigger, 2.3 times 10 to the minus 6 or 4.3 times 10 to the minus 9. In order to find out which number is bigger, which one has the higher concentration, 2.3 times 10 to the minus 6 molar or 4.3 times 10 to the minus 9th molar, we look at the exponent. We do not look at this number right here, 2.3. We look at the exponent to the 10. Whichever one of those is the bigger number, then we use, that's the bigger concentration. So minus a negative 6 or a negative 9. Which one's bigger? The negative 6 is a bigger number than the negative 9 because it's closer to 0. So the negative 6 number, that is the bigger number. So 2.3 times 10 to the minus 6 molar is bigger than 4.3 times 10 to the minus 9th. If you have trouble picturing that in your head, write this out in decimal form. So 2.3 times 10 to the minus 6, you're going to move the decimal to the left 6 places. So it will be 0.0000023. Or down here, we're going to move the decimal point 9 places to the left. So it will be 0.00000000043. So that makes 2.3 times 10 to the minus 6 a bigger number. And since it's bigger, that means the hydronium ion concentration is bigger, which means it is acidic. Now there's another formula we can use to find out the pH or the pOH of a substance. Now pH plus pOH is equal to 14. And now remember, if the pH is less than 7, it is acidic. If it is greater than 7, it is basic. 7 is neutral. So if the pH of a swimming pool is above 7.5, should you add an acid or a base? Now, typically people want their pH of their pool around 7.2 to 7.4 because that's about the pH of their eyes, which makes it very comfortable. You need to find out what would you have to do? What would you have to add? Would you have to add an acid or would you have to add a base to change the pH from a 7.5 to a 7.2? So we are lowering the pH, which means we have to make it more acidic. And if we do that, we have to add an acid. Now we have another problem. There are 2 clear solutions, and they are placed in separate beakers. The pH of the first solution is 4, and we don't know what the pH of the second solution is. But if we add the 2 solutions, we test the pH, and we find out that it's 5. So we have to find out what is it we know about the pH and the hydroxide ion concentration of the unknown solution. Well, we know the pH of the known solution is 4. Then we add the unknown solution to it, and the pH gets higher. So the pH is becoming more basic. It is not basic. It is still acidic, but it's more basic. Now, since we don't know how much of each solution that we added, the only thing that we know for sure is that it became more basic. So the pH of the second solution would have to be more basic than the first solution. So it has to have, the second solution has to have a pH greater than 4. Now the hydroxide ion concentration of the unknown solution, since the pH is higher, then we must know that it's more basic, so the OH concentration must be higher than the original solution as well. we need to calculate the pH if the hydronium ion concentration is 2.3 times 10 to the minus 4th molar. And then we need to find out if this solution is acidic or basic. So we are going to use the formula on our star reference sheet under solutions that says the pH is equal to the negative log of the hydrogen ion concentration. Now remember, hydrogen ion concentration and H3O concentration, we consider the same thing. We consider them equal. So the formula that we're going to use is the negative log of the H plus concentration. And remember, the H3O plus concentration, the H plus concentration are the same, and that equals pH. So our pH is going to equal to the negative log of 2.3 times 10 to the minus 4 molar. So our pH, if we plug that into the calculator, negative log of 2.3 times 10 to the minus 4, we are going to get a pH of 3.6. Now we have to ask ourselves, is this solution acidic or basic? Well, acidic solutions are always less than 7, and basic solutions are always more than 7. So this pH is less than 7, so it would be acidic. Now I would like for you to pause the video and do this calculation on your own and come back for the answer. Now let's do a calculation, a different type of calculation. So it says calculate the pH if the pOH is 12.3, and then is the solution acidic or basic? Well, pH plus pOH is equal to 14. So if we plug this in, if we're looking for the pH is going to equal to 14 minus pOH. So pH is going to equal 14 minus 12.3. That would make the pH 1.7. And if the pH is 1.7, it must be acidic, because acidic solutions have a pH of less than 1.7. I would like for you to pause the video and do this calculation on your own. Remember, you're going to use the hydronium ion concentration times the hydroxide ion concentration is going to equal to the ionization constants, which is 1.0 times 10 to the minus 14 molar.